This is section 12.5, and we're going to talk about expanding polynomials, or expanding binomials actually. And so the formula for expanding x plus a to the n, you know how to do. This is x plus a to the first power. We know how to expand to a quadratic. We even probably have done x plus a to the third, where you would do it first squared and then you'd multiply it again one time by x plus a. But the bigger your exponent gets, the more that gets to be a little bit of work. Now, one thing that I wanted you to know, that when you're going to the second power, the sum of the exponents in each term is 2. When you're going to the third, the sum of the exponents in each term is 3. 4, you see here we have 4, and so that's something to remember. And we're not going to be doing things by hand, but this was some interesting notes about how to generate Pascal's triangle. You are given Pascal's triangle in a handout, and if not in the handout, it is in these lecture notes. So Pascal's triangle looks like this, and it starts out with 1. And the second row is 1, 1. So this is 0, 0 row. This is to the first power. This is to the second, to the third, to the fourth, fifth, sixth. And in here, you could build it because 1 and 2 becomes 3, 2 and 1 becomes 3. 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and then there's a 1 on the outside. So you could build it, but you've got it here, and you're going to use that to do some of your problems. So if you were supposed to expand x plus 2 to the fifth, here's the process to do that. We're going to first take the fifth line, because we're expanding to the fifth power. So we're going to write this line down, 1, 5, 10, 10, 5, 1. Then we know we're doing x and 2. We'll take the x first, and we raise it to the fifth power, and then we descend. So we have x to the fifth, x to the fourth, to the third, to the second, to the first, and then x to the 0, which doesn't show up. Then we take the 2, and we start with the 0 part here, and then 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. So we are ascending with that one. Once you get that done, you're going to put these numbers from the fifth row in front. I did that in red, okay? And so now the final answer is going to be x to the fifth. I'm going to multiply 5 and 2, so I have 10x to the fourth, 40x to the third, 80x squared, 80x, and 32. And that's what you get if you multiply this by itself 5 times. All right, the other thing that we have to do in a few of the beginning problems is to do some combinations. This is what we would do to arrive at the numbers in the Pascal's triangle, and so we are going to do some combinations. And if you do it in the calculator, you go to math, probability, number 3. Let me grab my calculator up here, and we'll talk about that. So let me clear this. If you go to math, over to probability, and choose number 3, NCR, then you can put in, if you're taking 6 on the top and 4 at the bottom, you would do 6 there, right arrow, and put 4, and hit enter. And so that's how you would do that. If you have an older calculator, you may have to do it in a little bit different order. You would have to, because you may not have that icon, you would maybe hit the number 6, then go to math probability and get NCR, and then type the 4. So you would have this on your calculator. If you have the older TI-83, it would still equal 15. So let's go look at the problems and see what they look like. We just have 7, and the first 2 are vocabulary. Blank is a triangular display of the binomial coefficients. That's the Pascal's triangle. The second one, the blank, can be used to expand expressions like 4x plus 1 to the 6th. That's the binomial theorem. So those two things, good. Then number 3 and 4 are combinations. That's what we just talked about. 4 things taken one at a time. So it's 4 at the beginning, C, 1, and then 5 and 2, and you would get those. The last 3 are using the expansion. So x plus 3 to the 6th, we'll use the 6th row of Pascal's triangle, and that is 1, 6, 15, 20, 15, 6, 1. And notice the symmetry, 20's in the middle, and the same things going backwards on either side. So we'll take the x first, and we'll have x to the 6th, x to the 5th, the 4th, the 3rd, the 2nd, the 1st, and the 0. Then we'll take the 3, and we'll start here, and it'll be to the 0, 1, 2, 3, 4, 5, 6. Those 3 to the 0 and the x to the 0, they just disappear because they become 1. Then we'll put these numbers in front, 1, 6, 15, 20, etc. So then after we've put the red numbers in there, we just clean it up. So we've got x to the 6th, that's all just 1. 6x to the 5th, but we multiply 6 times 3, so we have 18x to the 5th. 3 squared is 9. 9 times 15 is 135, x to the 4th. 3 cubed is 27 times 20 gives you the 540, x to the 3rd. 3 to the 4th is 81. You multiply that by 15 and you get this number. And then 6 times 3 to the 5th. Did I miss one? I don't know where I missed. This one is going to be just 3 to the 6th, which is 729. And then this one, I think I left out one. There should be another one there. Okay, I think I fixed that. I had the squared term, and I had left out writing this one. So this should be the 1458x to the 1st plus 729. So that should be the terms for that one. All right, number 6, x minus 3 to the 6th. That's the same terms, but because it's got a minus, you will alternate the terms. So just know that if you have a minus there in that position, you're going to start out positive if it's to the 6th, and then you're going to alternate signs. The last one is to the 5th, but it has x to the 5th, y to the 7th. So use row 5 of Pascal's triangle. That's this one here. Then we have x to the 5th to the 5th, x to the 5th to the 4th, x to the 5th to the 3rd, to the 2nd, to the 1st, and to the 0. So put that in parentheses. Then you have y to the 7th to the 0, to the 1st, to the 2nd, 3rd, 4th, 5th. Remember, with the second one, you are going up, and the first one you're going down. Then when you do power to power, you multiply. So this is x to the 25th. This is 0, so that becomes 1. Then we have, because we put these numbers in, so the red numbers are there. We've got 5x to the 20th, y to the 7th, 10 x to the 15th, y to the 14th, 10 x to the 10th, y to the 21st, 5 x to the 5th, y to the 28th, and 1 x to the 5th to the 0, so that goes to 1, and we just have y to the 35th. And so that's that one. So those aren't too bad. It's mechanical. You should be able to follow it with the Pascal's triangle. That should get you through 12.5.